Hello class. Today we are going to look at combining like terms within a function. So what does that mean? In a function, if two things are alike, they can be combined if they're added or subtracted. Okay, we just have to add or subtract them. The caveat here being they have to be alike. Okay, so if I look at this first operation here and I go about simplifying it, it says 2x plus 4x. Now they've already solved the first one for you. It equals 6x. Alright, the reason I can combine these is they both have an x. Okay, so because they both have x in the term, I can just add the 2 and the 4 out front and combine them. Alright, if there would have been an additional term plus 5, I wouldn't be able to combine just a plus 5 with the 4 and the 2, because as you can see, if I added a plus 5 here, if the equation originally was 2x plus 4x plus 5, I'd have to have just the plus 5 by itself in the answer as well, because it doesn't have an x on it. Okay, so we can combine like terms, and what we mean by like terms is that the terms themselves have something alike in them, aka the variable is alike, or either they don't have a variable at all and then they can be combined. Okay, so let's look at some more examples, kind of get in the flow of what we're doing. The next one says 2y minus 3y. They do have like terms, they both have a y. Okay, 2y minus 3y. Okay, 2 minus 3 is negative 1, so I'm looking at negative 1y. Okay, I was able to combine them because they had like terms. I now have 5a plus 7a. The like term here is the a, and they are alike. Both of them have an a. 5 plus 7 is 12, so I have 12a. Not meant to be very difficult. The next one is n plus 8n. I can as well combine these. They both have an n in them. Now this n doesn't have a number in front of it, but it's assumed to be 1. Okay, so this is essentially the same thing as 1n plus 8n. Okay, 8 plus 1 is 9, so we have 9n. So if you ever just have a variable by itself and you're adding it to another like term, you have to assume that that's a 1 in front of it. Okay, so that you can add or subtract that 1. Alright, here we have negative 2m plus 7m. We do have like terms here. The like term itself, the variable is m, so I can combine these. Negative 2 plus 7 is going to give us a 5, so I have 5m. And the next one I have 3y minus 10y. Okay, like term here is the y. 3 minus 10 is negative 7, so I have negative 7y. Like I said, hopefully you can tell it's not meant to be really difficult. Alright, I have 12b minus 4b. Here the like term is the b's. So 12 minus 4 is 8. This simplifies down to 8b. Up next I have 9a plus 5a. My like term is my a's. They both have it. So I can combine the 9 and the 5. 9 plus 5 is 14. That gives us 14a. Negative 15x minus 4x. Okay, the like term here is x. And I can combine the negative 15 and the negative 4 to get negative 19x. Okay, I like to put equal signs. Alright, up next we have negative 14r plus 8r. The like term here is r. Negative 14 plus 8 is going to give us negative 6r. Okay. Up next I have k minus 11k. Remember, there's assumed to be a 1 out front here. So this is essentially 1k minus 11k. 1 minus 11 is negative 10. So I get negative 10k. Try to put my equal signs. Alright, b minus 13b. Remember, there's a 1 assumed to be out front. 1 minus 13 is negative 12. So I have negative 12b. 6c plus 8c. These have like terms. So 6 plus 8 is 14. So that gives me 14z. 10z plus z. Remember, if there's not a variable out in front, it's assumed to be 1. 10 plus 1 is 11, so I have 11z. Here I have negative 9m plus 4m. We've got like terms. So negative 9 plus 4 is negative 5, so I have negative 5m. Alright, so that went pretty easy. Let's see if we can complicate it a little bit. Okay. Another worksheet here. We want to simplify by combining like terms. Okay. We'll go ahead and start out with a little bit harder one that looks a little different. This is negative 13 n squared plus 11 n squared. Okay. Now, our like term in these, I even changed my color just to highlight it. My like term in these is the n squared. Okay. If both of these n's didn't have a square on them, they wouldn't be alike. The entire term itself has to be alike, including the exponent. Okay, so here these are both alike. They both have an n squared. So we're able to do negative 13 plus 11, which gives us the negative 2 n squared. Have to add our like term there. All right, if I look at the next one, it says 8r minus 10. Do I have like terms here? That's the main question we're going to start with. Do I have like terms here? The first set here has an 8r, but the second set is just a negative 10. It does not have an r on it. I don't have like terms between the two sets here, so I cannot combine them. All right, so the literal simplification of this is already as simple as it can go. It's just 8r minus 10. Okay, if it doesn't have the same variable in each, I can't combine them. Here I have an r, here I don't have anything, so there's nothing I can do. All right, my like term in the next one here says 18x squared plus 19x squared. These do have like terms. The like term here is the x squared. They both have an x squared, so they can be combined. 18 plus 19 is going to give us 37x squared. Okay. All right, let's look at the next one. I have 15a minus 8b. These both have terms, but they're not like terms. Okay. They both have variables. The first one has a variable of a. The second one has a variable of b, but they're not like. Okay. So this is different. So I can't combine them. I can only combine them if they're like terms. These are different terms. So, because I can't combine them, that means this is already as simple as it can go. And I have 15a minus 8b. Alright. Next one says 22m minus 9m. These do have like terms. The like term here is the m. So 22 minus 9 is going to give us 13m. Okay. Didn't really mean for that to look like a B. So I'll rewrite that just so you can tell. Alright. Next up we have negative 13y plus 17y. This set does have like terms. Okay, so we're going to combine them. Negative 13 plus 17 is 4y. Very nice. Alright, up next I have negative 23b minus 16b. Okay, these do have like terms. Negative 23 minus 16 is going to give us negative 39b. Alright, up next I have a squared plus 25a squared. These do have like terms. The like term is the entire a squared. Okay, and remember, just like the first worksheet, if there's not a number out in front of it, it's assumed to be 1. So here, 1 plus 25 is 26 a squared. Alright, up next I've got negative 5x minus 28x. The like terms here are the x's, so I can combine these. I've got negative 5 minus 28. That's going to give us negative 33x. Okay. Alright, let's keep going. I've got 5b plus 16c. Are these like terms? No, they're not. B and C are not like terms, so I cannot combine them, and I just have to leave it as 5B plus 16C. Up next, I have 14V minus 18V. V is my like term in both of these numbers here. So I've got 14 minus 18 is going to give us negative 4V. Okay. Here I have negative 7W plus 13W. They do have like terms. Negative 7 plus 13 is 6. So I have 6W. Here I've got 26D plus 12D. Okay, my like term here is the D's. 26 plus 12 is going to give me 38D. Okay. My like term in the next one, it says negative 21Z squared minus 13Z squared. My like term here is the Z squared. They both have a Z squared, so they can be combined. Negative 21 minus 13 is going to give us negative 34Z squared. Last but not least here, I've got 15M squared minus M squared. Okay. All right, remember if it doesn't have a number out in front, it's assumed to be 1. So I have 15 minus 1 is 14M squared. And that is it simplified. So remember, when we're simplifying functions, what we want to do is combine like terms. Okay? We're looking for something that's the same. Here we messed primarily with like terms that have variables in them, but you could have a scenario where you had 3x plus 4 plus 8. Okay? We don't have like terms between 3x and 4 or 3x and 8, but 4 and 8 are considered like terms because neither have a variable. Okay? So this could simplify to 3x plus 12. So keep in mind that like terms can be combined throughout the entire function. We did very simple examples here, and these functions can get very, very complex as you continue on with very, very many different pieces and parts that need to be combined. Okay, you can combine 2 pieces, 3 pieces, 20 pieces, and you might not be able to combine any pieces. Okay, but we do try to combine as many pieces as possible, as mathematically possible, without breaking any mathematical rules, in order to simplify the function down as far as possible. So, come back next time. We'll get further in it with some more function rules on how to simplify, and I'll see you then.